Getting started with the OpenAI API in Python. Welcome to your first lesson on using the OpenAI API. We will learn how to talk to AI models from your own Python code. Let us start by exploring what the OpenAI API can do. Running the cell now. What is the OpenAI API? The OpenAI API lets you access advanced artificial intelligence models. You can generate text, analyze meaning, and much more. All you need is an API key and an internet connection. Running the cell now. Why use the OpenAI API? It saves you from building huge AI models yourself. You can write simple code to solve hard problems. Many real-world apps use this approach, like chatbots and voice tools. Running the cell now. First, let us make sure we do not see warning messages. This keeps our output clean and simple. We ask Python to ignore warnings. Import numpy as np. We set the random seed to 42 for reproducibility. Warning messages are hidden. Running the cell now. This code sets up the environment by ignoring warning messages and ensuring reproducibility with a fixed random seed. Notice there's no visible output because these settings prepare your workspace quietly, so your focus stays on building AI features without distractions. This step highlights how simple code tweaks can streamline working with complex AI APIs. Now our notebook will stay tidy. Installing the OpenAI package. The OpenAI library connects Python code to the OpenAI API. Let us check if it is installed. If not, we will install it together. Running the cell now. Now let us make sure the OpenAI package is ready. This will install OpenAI if you do not have it yet. We attempt to import OpenAI. If the import works, we continue. If the import fails, we will run the next lines. We bring in system so we can use the right Python interpreter. We install OpenAI using pip, which manages packages. This just tries to bring in OpenAI. If OpenAI is missing, these lines will install it and try again. Running the cell now. This code snippet attempts to import the OpenAI package and installs it if it's missing, ensuring the environment is ready for OpenAI API use. The lack of output means no errors occurred, confirming the package is now available. This step is essential before proceeding with any API calls in the lesson. Great, now we have the library we need. API key, keeping your credentials safe. You need an API key to connect to OpenAI. The API key is like your personal password for the API. It is already saved in the environment, so we do not need to enter it here. Running the cell now. We will grab the API key from your environment variables. This keeps your credentials private and secure. We import OS, which lets us interact with your system. We will ask for the OpenAI_API_key stored in your environment. Now the API_key holds your secret key without showing it. We do not show your key to keep things safe. Running the cell now. Here, the code securely retrieves your API key from the environment without displaying it, emphasizing best practices in credential management. Notice there's no printed output, which is intentional to keep your key private and protect your access to the API. This step ensures your sensitive information stays safe while allowing your program to authenticate properly. Your API key is ready for use in the rest of the lesson. Introducing the OpenAI client. The OpenAI library gives us a client object. This object is our main tool to talk to the API. Let us start by creating a client instance. Running the cell now. We will prepare the OpenAI client, your main contact for the API. We import the OpenAI class from the library. Here we create a client instance by calling OpenAI. OpenAI gives us a client object. We are ready to make requests, but nothing has happened yet. Running the cell now. Here, creating the client object sets up our connection to the OpenAI API but does not produce any output or send data yet. This step is foundational. It prepares us to make requests in later code by establishing the main interface to the API. Notice that simply initializing the client is silent, reflecting that no actions or queries have occurred so far. Now we can use this client to access AI power. Key concepts, models, prompts, and responses. Model, the specific AI brain we use, like GPT-4.1 Mini. Prompt, the message or question we send to the model. Response, the model's answer to our prompt. You can chat, summarize, generate code, and more. Running the cell now. Let us see how to send a message to a chatbot and get a reply. We are about to request a chat completion from the model. Here we ask the model GPT-4.1 Mini to join the conversation. We list our message as if we are the user, saying hello. This makes the API think it is answering a real person. We run the request and save the result in response. Now we print the model's reply message. Running the cell now. This output shows the model's response to our simple greeting prompt. Notice how the AI, using the GPT-4.1 Mini model, replies conversationally, demonstrating how prompts generate relevant, natural responses. This highlights the core interaction of sending a message, prompt, to the model and receiving a meaningful reply, response. This is your first message to the OpenAI API. Now let us make the AI greet you personally. We will ask for your name, then tell the model to say hello to you. We let the user know we'll ask for their name and greet them using ChatGPT. We ask the user to enter their name using input. We create a message string that says say hello to user_name. We call the chat completion API to generate a response. We specify the model to be a GPT-4.1 Mini. We provide the chat messages with the user's message for the model to respond to. We print the content of the AI's reply from the response object. Running the cell now. This output shows the AI model responding to a personalized prompt where the user's name, Alex, is included in the message. Notice how the model's response directly greets the user by name, demonstrating how dynamic prompts shape the model's replies. This highlights the key concept that the *prompt* influences the *response tailored to input data. This shows you can put together your own prompts and send them to AI. Exploring different endpoints of the API. There are special API tools for different jobs. For example, you can ask for text, embeddings, sound, or run code. Let us try making text embeddings next. Running the cell now. Embeddings turn words into numbers computers can understand. Embeddings help search, similar meanings, and more. This comment explains that the next step is to create an embedding for a short sentence. We call the embeddings create method on the client object to start the embedding process. We specify the model that specializes in generating text embeddings. We provide the input list containing the sentence to be embedded. The method call is closed, completing the request setup. We print the length of the embedding vector returned for the first input sentence. Running the cell now. Here, the code generates a text embedding for the sentence. Machine learning is fun using a specialized embedding model. Notice the output 1536, which indicates the length of the embedding vector, a fixed-size numeric representation capturing the sentence's meaning. This shows how the API returns consistent, high-dimensional embeddings useful for tasks like similarity or clustering. You just created your first embedding with the API. The API can turn text into speech as well. Let us have it say hello world and save the result as an audio file. Let us perform text-to-speech and get audio back. We open a file named voice.mp3 in write binary mode to save the audio output. We call the audio speech creation function from the client. We specify the model to use for text-to-speech conversion. We set the voice option and provide the input text to hello world. We write the returned audio data to the file. Running the cell now. This code sends a text input to the API's text-to-speech endpoint and saves the resulting audio to a file named voice.mp3. Notice there's no printed output because the main result is binary audio data, illustrating how the API can generate sound files directly from text. This demonstrates how different endpoints serve specialized purposes beyond just returning text. Now you can play the MP3 and hear AI-generated speech. Now let us use the API to understand spoken words. We will send an audio file, and the AI will try to write the words it hears. This comment indicates that the following code transcribes an audio file to text. We open the audio file named sample.wav in binary read mode. We start a call to the client's audio transcription creation method. We specify the model to use for transcription as a Whisper 1. We provide the opened audio file as the input to the transcription method. We close the method call and assign the resulting transcript object. We print the text content of the transcript returned by the AI. Running the cell now. Here, the code attempts to transcribe audio using the Whisper model, demonstrating how the API can convert speech to text. The file not found error indicates the audio file sample.wav is missing, highlighting the importance of providing the correct input files when using specific endpoints. This lesson reminds us that different API tools require appropriate data to function properly. You can use this to turn meetings, calls, or voice notes into text. Sometimes you want a single, clear answer. The responses endpoint helps with tasks where you want one straight answer. Let us use the responses endpoint for precise output formatting. We call the create method on the responses client to generate a response. We specify the model we want to use for generating the response. We provide the string input, which is a question about embeddings. We print the text of the first content piece from the first output in the response. Running the cell now. This output shows a concise definition of embeddings generated using the responses endpoint, highlighting how this API tool can produce well-formatted, precise text answers. Notice the clear explanation in one sentence, demonstrating the endpoint's ability to tailor responses exactly to the input prompt's intent. This makes it easy to use the API in chatbots, tools, or education. Let us see what happens if you use an invalid model name. Errors are common, and handling them helps you avoid crashes. We add a comment explaining the purpose of the following code. We start a try block to catch any errors that occur. We attempt to create a chat completion using the client. We specify a model name that does not exist to cause an error. We provide the input messages for the chat completion request. We close the function call properly. We handle any exception that arises during the try block. We print a message showing what went wrong. Running the cell now. This output shows a handled error triggered by using an invalid model name, resulting in a clear model_not_found message. Notice how the code safely catches and prints the error instead of crashing, demonstrating good practice when exploring different API endpoints and models. This helps you understand how to gracefully manage mistakes while trying out new tools like text embeddings. This keeps your programs running even if there is a mistake. The API can call your code if you tell it how. Let us teach the AI a simple addition function. We start with a comment describing that this is a simple function call example using the API. We define a function named add with two parameters, a and b. The function returns the sum of a and b. We create a variable resp to store the response from the client chat completion call. We specify the model to be a GPT-4.1 for this chat completion request. We send messages containing a single user message asking to add 3 and 5. We specify a list of functions to the API that the model can call, starting with the opening bracket. We define one function object, starting with an opening brace. We name the function add. We add a description for the function, add two numbers. We start defining the parameters object for the function. We specify that the parameters are of type object. We define the properties of the parameter object, starting a dictionary. We specify that a is a property of type number. We specify that b is a property of type number. We declare that both the and b are required parameters. We close the parameters dictionary. We close the function object. We close the list of functions. We specify that the function call behavior should be automatic. We print the response object to output the result. Running the cell now. Here, the output shows the API successfully recognized the user's request to add 3 and 5 and prepared a function call with the correct arguments. Notice that the function _call field includes the JSON with parameters A3, B5, confirming the model's ability to route tasks to specialized functions automatically. This demonstrates how integrating function calls enables precise control over the model's behavior within different API endpoints. This unlocks automation and teamwork between your code and the AI. Good practices for the OpenAI API. Never share your API key. Protect it like a password. Test with small models at first. Upgrade models for higher quality when needed. Catch errors so your app does not crash if the network fails. Limit sensitive information sent to the API. Running the cell now. Let us combine what we learned. We ask for your favorite color, then test if the AI can remember it. This is a comment describing the mini project purpose. Get the user's favorite color using input. Create a prompt that tells the bot to remember the color and ask it to recall it. Call the Chat Completions API to create a chatbot response. Specify the model to use for the chat completion. Provide the user's message to the chatbot in the required format. Close the function call for the chat completion. Print the chatbot's remembered color from its response. Running the cell now. This output shows the chatbot successfully recalling the user's favorite color, demonstrating how the prompt captures and sends user input to the API. Notice how the small model's GPT v4.1 mini handles the task efficiently, aligning with the lesson's advice to start with lightweight models before upgrading. It reinforces the good practice of testing interactively while ensuring your code gracefully processes user data without exposing sensitive info. Now you have a personalized conversation with your AI. If things are not working, it may be due to the key or network. Let us wrap a request in a try-except block to handle both. This is a comment to explain what the try block is for. Start a try block to attempt running code that might fail. Try to create a chat completion using the client object. Specify the model to be used for the chat completion. Provide the messages parameter with a user message asking, "Am I connected?" Close the function call. If it succeeds, print a confirmation message that you're online. If there is any exception, catch it as the error. Print that the connection failed along with the error message. Running the cell now. This output shows a successful connection to the OpenAI API, confirming the code can communicate without errors. In this lesson section, the try-except block demonstrates good practice by handling potential network or key-related failures gracefully. Notice how this prevents your app from crashing and helps verify your setup before moving to more complex tasks. This helps if you run into problems connecting to the API. Challenge Exercise 1. Ask the user for a hobby. Have the Chat API suggest one creative use for their hobby. Print the result. Running the cell now. Let us see how to solve the first challenge. We will ask for your hobby, send it to the chatbot, and print a creative idea. We add a comment to describe the purpose of this code snippet. We ask the user to enter their hobby using input. We create a prompt string that asks for a creative way to use the hobby. We call the Chat Completions API to generate a response. We specify the model to be used for the completion. We provide the user's message as input to the API. We print the content of the API's response message. Running the cell now. This output showcases the Chat API creatively responding to the user's hobby input, photography, by suggesting a detailed project idea. Notice how the response is specific, actionable, and tailored to enhance skills relevant to the hobby, demonstrating the code's intent to generate personalized and inspiring suggestions. This confirms the success of collecting user input, forming a prompt, and engaging the Chat API to produce meaningful, hobby-related advice. Try new hobbies to see more creative ideas. Challenge exercise 2. Write a function that asks the model to summarize any text you provide. Test the function with a few sample sentences of your choice. Running the cell now. Let us write a helper function for text summarizing. You can input any sentence and get a short summary. This is a comment describing the purpose of the function below. We define a function named ask_for_summary that takes one argument, the text to summarize. Inside the function, we create a prompt string by embedding the input text. We call the Chat Completions API on the client to generate a completion. We specify the model to use for the completion request. We pass the prompt as a user message to the API in the required format. We return the content of the first message choice from the API response. We prompt the user to type some text for summarization. We call the ask_for_summary function with the user's input and print the resulting summary. Running the cell now. This output shows the concise summary generated by the model in response to the user-provided text, demonstrating the function's ability to produce clear, relevant summaries. Notice how the summary captures the main idea in a brief, coherent sentence, aligning with the exercise's goal to create a reusable summarization function. You now have a summary tool using OpenAI. Recap of what you learned. You explored different parts of the OpenAI API. You sent chat messages, made embeddings, voice, and handled errors. You also built mini-projects and solved challenges. Great job reaching this milestone. Running the cell now. Want more? Subscribe and keep learning. Try out your own creative projects with what you learned. Subscribe to the channel to stay updated on new Python lessons. See you next time. Running the cell now.